Let's solve the trig equation. 2 secant theta minus 3 equals negative 5.86 in 4 steps. Not too bad. 4 simple steps, I'll say. This is a trig equation because the unknown is an angle as part of a trig equation. And there's more directions to this equation than just to solve the equation. We want to solve it where theta is an angle between 0 degrees and 360 degrees. This equation actually has an infinite number of solutions, but we'll only find the solutions between 0 degrees and 360 degrees. Most of the time, trig equations that look like this will have 2 solutions between 0 and 360 degrees. This one does. Additionally, the solutions, those 2 solutions, will be irrational numbers, but we're going to round them off to the nearest tenth. Let's begin. Step 1 is to isolate the trig function. And isolating the trig function, in this case secant of theta, can be accomplished with some fairly basic steps of algebra. We'll add 3 to both sides of the equation, then divide both sides by 2, and the secant of theta will be isolated. First, adding 3 to both sides makes the right side of the equation negative 2.86. Negative 5.86 plus 3 is negative 2.86. And then finally divide both sides of the equation by 2. And we get the secant of theta equals negative 1.43. The trig function, secant of theta, has been isolated, so we can move to step 2. Step 2 is to identify what 2 quadrants the solutions are in. Earlier I said that this equation, like most equations of this type, will have 2 solutions. And the 2 solutions will be either in quadrants 1, 2, 3, and 4. And that depends on whether the secant of theta is positive or negative once you isolate it. And here, after we isolated the secant of theta, we got negative 1.43. And the secant is negative in quadrants 2 and 3. The secant is negative in quadrants 2 and 3. If you take the secant of an angle between 0 and 90 degrees, which is quadrant 1, you'll always get a positive number. If you take the secant of an angle in quadrant 4, any angle between 270 degrees and 360 degrees, that will also be positive. But the secant of any angle in quadrant 3 and quadrant 2 will always be negative. So since this trig equation, when the secant is isolated, the secant of theta equals a negative number, the 2 quadrants the solutions are in are quadrants 2 and quadrants 3. So there will be 2 solutions. One of the solutions, the quadrant 2 solution, will be between 90 and 180 degrees, and one solution, the third quadrant solution, will be between 180 and 270 degrees. Now that we know the quadrants of the solutions, we're going to use the inverse trig function. I have the secant of theta equals negative 1.43. But in this step, I'm going to take the inverse secant of the positive version of the number. I'm going to do inverse secant of 1.43. That will make my next step a little easier, and we'll discuss in step 4 how to find our final solutions. The inverse secant of 1.43 is, well, my calculator doesn't have an inverse secant key, but remember, the secant is the reciprocal of the cosine. So I can actually use the inverse cosine to find this solution. And the way that I do that is I'll do the inverse cosine of the reciprocal of the number. Inverse secant of 1.43 is exactly the same thing as the inverse cosine of the reciprocal of 1.43. So what I'll type into my calculator is inverse cosine of 1 over 1.43. This will be irrational, but I'll round it off to the nearest tenth, and it's 45.6 degrees. 45.6 degrees. Remember, in step 2, I said that our solutions are going to be in quadrants 2 and quadrant 3. This 45.6 degree angle is first quadrant angle, but it will be the reference angle that we'll use to find our second and third quadrant solutions to this equation. That's what we'll do in step 4. And step 4, our final step, is again to use reference angle formulas to state the two solutions. In degrees, the reference angle formulas are this. If you know a first quadrant angle, you can find an associated second quadrant angle by taking 180 minus that angle, 180 minus theta. And if you know a reference angle and you want to find the associated third quadrant angle, which is what we want to do also, we use 180 plus theta. Let's do that now. Again, I'm recalling that in step 2, I identified that my solutions will be in the second and the third quadrant. So I'm using the two reference angle formulas that I've circled. First quadrant 2, 180 minus 45.6 is 134.4 degrees. That's one of the two solutions to the original equation. The quadrant 3 solution will come from 180 plus the reference angle of 45.6, and that sum is 225.6 degrees. That's the other solution to the original equation. So we have our two solutions. We're done with step 4. The two solutions are 134.4 degrees and 225.6 degrees. I'm going to finish up this problem by checking those two solutions. To check these two solutions, I'll simply substitute them for theta in this original equation and make sure I get negative 5.86. Or, because I rounded off those solutions, make sure I get about negative 5.86. My quadrant 2 solution was 134.4 degrees. Again, my quadrant 3 solution was 225.6 degrees. Let's first check 134.4. And I'll do that check by substituting 134.4 into the original equation. Do 2 times the secant of 134.3, or 134.4 minus 3. I want to make sure that that's negative 5.86. Now again, my calculator doesn't have a secant key, but the cosine and the secant are reciprocals. So instead of entering secant of 134.4, I'll enter 1 over cosine 134.4. The secant and the cosine again are reciprocals. When I enter that reciprocal with the cosine, multiply by 2 and subtract 3, I get negative 5.858, which again is not exactly negative 5.86, but because I rounded off, it's close enough. 134.4 is definitely one of the two correct answers. Now let's check the 225.6 degree solution the same way. Substitute it for theta, and again, instead of the secant of 225.6, I'll type into my calculator using the cosine as its reciprocal, 1 over cosine 225.6 times 2 minus 3 is equal to negative 5.858, same thing, which again is close enough to what I was looking for in the original equation since I rounded off my solutions. 225.6 checks out as well. That's the other solution. Now that I've checked my answers, I'm confident to say that the two solutions between 0 degrees and 360 degrees of 2 secant theta minus 3 equals negative 5.86 are 134.4 degrees and 225.6 degrees.